In this video, we're going to look at writing three types of reactions. And the three types of reactions that we're going to look at writing are the chemical, the complete ionic, and the net ionic reactions. And so first, we're going to start with this example, question number 15. And we're going to start with magnesium sulfate. So we're going to write the formula for magnesium sulfate. I know that magnesium is a 2+ because it's in column 2A. And I also know that sulfate, I can look in the back of the periodic table to find sulfate. It's a polyatomic ion. It's a SO4 2-. So I'm going to start by writing, so the complete or chemical equation is going to start with magnesium sulfate. Magnesium, as I mentioned, is a 2+, and sulfate is a 2-, so it goes together as MgSO4. I'm going to look at this sheet here in magnesium and find sulfate, the solubility table, and it's soluble. So that means I'm going to put an AQ on the end, meaning that it's going to dissolve. And question number 15 is stating magnesium sulfate is reacting with calcium chloride. And so I need to take a look at calcium chloride. Calcium is a 2+. It's in column 2A. And chlorine from column 7A is a 1-. So I'm going to need 2 Cl's to match the 1 Ca. So CaCl2. 2 Cl's for every Ca. I find the Ca and I find the Cl, and it is also soluble. Because it's soluble, that means it's going to be in an aqueous solution. So we have our two reactants. And this will be a double replacement reaction. You have substance A and substance B, substance X and substance Y, and so they're going to switch. So I'm going to let Mg bond with Cl. Well, the way Mg and Cl bond, Mg is a 2+, Cl is a 1-, so it's also going to be MgCl2. And I'm going to look at my chart, and Mg and Cl is also soluble. So I'm going to put AQ, and then plus Ca is going to go together with SO4. Now we're not going to write SO4 first because SO4 is the minus and Ca is the plus. Ca is a 2+, column 2A. SO4 is a 2- on the back of your periodic table, the polyatomic ion chart. So we come together as CaSO4. We don't need to put anything in parentheses because it's just one Ca as a 2+, one SO4 as a 2-. So I find Ca and SO4, and I look, and this slightly soluble, anytime we have slightly soluble, we're going to allow that to move to insoluble. If you have slightly soluble and the other substance is soluble, then it goes to insoluble. If you have slightly soluble and the other substance is insoluble, then it goes to soluble. So it goes the direction of the opposite. So this we're going to put as a S for solid, because we're going to be saying that this slightly soluble is actually insoluble since the magnesium chloride is soluble. This is the chemical equation. Now I need to check to make sure that it's balanced. 2 Cl's, 2 Cl's, Mg, Mg. Looks like everything is balanced. The next thing that it asks for is the complete ionic equation. So what we're going to do when we write the complete ionic equation, the complete ionic equation is showing the substances as they actually exist. Showing the substances as they actually exist. So what that means is here we're writing MgSO4 as an aqueous solution, but we know if it's an aqueous solution, it really isn't together as MgSO4. It's broken up into its individual ions. The definition of aqueous solution is that it has been placed into water and it has dissolved. So this really isn't MgSO4. Really what it is it's Mg2 plus ions plus SO4 2 minus ions. Really, this is broken apart by the water molecules into its individual ions. So when we say that it's aqueous, really what we're saying is it's separated into its individual ions in the water. Same thing with the CaCl2. We're writing it as CaCl2 aqueous, but really it doesn't exist as CaCl2. It exists as Ca2 plus ions plus, now, if I were to take this CaCl2 and break it apart into its ions, really we get one Ca2 plus, but we get two Cl minuses. This breaks apart into two Cls. And if we were putting the formula together, you know that, Ca with two Cl minuses. So when we write that, we have to actually write it as 2 Cl minus aqueous. Then we're going to write the arrow. And then this, of course, breaks up into its individual ions as Mg2 plus aqueous plus, and once again, this breaks up into 2 Cl minus aqueous. And then I can't quite fit it here, so I'm just going to write it under here. Plus, now, here's where things change. Notice all of these were aqueous solutions based off of being soluble. So when they're placed into water, they're broken apart into their individual ions. Here, though, because it was slightly soluble, we said it was going to be insoluble, so it forms a solid precipitate. This does not break up into its individual ions. It stays as CaSO4 as a solid precipitate. And once again, this piece should be over here. I just couldn't fit it on the page. So that is the complete ionic equation. And then finally, we need to write what's called the net ionic equation. The net ionic equation shows only substances that changed. So anything that changed during the reaction will be shown. For instance, Mg2 plus started as Mg2 plus and ended as Mg2 plus. Notice the Mg2 plus never changed. Nothing happened. Look at Cl minus. Cl minus started as Cl minus and it ended as Cl minus. All of these ions never changed. They started floating around in the water at the beginning, and they're still floating around in the water at the end. So what we're going to do is only write the things that changed. I'm going to write the Ca first just because it's the positive one. It doesn't have to be written first. So Ca2 plus SO4 2 minus in an aqueous solution floating around, and they are so strongly attracted to each other, they stick together to form a solid precipitate. And this is our net ionic equation. Notice the net ionic equation does not involve anything that didn't change. All the things that didn't change, the boxes up above, These boxes are called spectator ions. Spectator ions are ions that do not change. They are spectating. They are just watching other things change, and nothing happens to them. They started as ions, and they ended as ions. Spectator ions, ions that did not change during the chemical reaction. And those are called spectator ions. So this is a summary of the overall chemical equation, the complete ionic equation, and the net ionic equation.